All right, today we're going to do a pressure dependent VAV. If anyone knows what that is, so there's pressure dependent, pressure independent. Pressure independent uses the flow tubes. You have flow settings that usually control the VAV. Pressure dependent does not use flow tubes, so it has no idea what the flow is going through it. And that's not a standard function on Johnson controls. So we have single duct, dual duct, and subordinates. So when we choose single duct, nowhere in here allows us to have pressure dependent. So we're going to have to make this up. I'm doing this for the boxes in our office. So I'm not going to use supply air sensors because we don't have those. They're cooling only boxes, so I took away the heat. We are going to have common set point adjust. And that's it. So finish. This is going to build this for us here. But if we go and look at the damper output, it's controlled by supply damper control. So if we go there, it's looking for a flow, right? So we don't want that. So, but I do want to know what kind of mode this is. So I'm going to go ahead and double click in it and go in there. And it's VAV flow control mode. So what I'm going to do here is make it hybrid activity. And call it VAV control. Finish. All right. So now I can go and view the logic here. Scroll a little bit. I'm going to change this to VAV flow control. Mode. And now I'm going to make an activity input. Call it mode. And VAV flow control. Apply. And then we're going to hook this guy in here, right? And I already know I'm going to need an output on everything, so it's going to be a floating output. I'm going to zoom out a little bit more. So I got some room. And we'll call this damper command. C. Enough for me. So we know in close mode, I'm just going to do a constant float, connect air. I'll go ahead and make this a 0 so we know it's a 0. It's already a 0 here, so we don't have to do anything else. That way, if we're looking at it, we see that it's 0, right? Open. We'll do a constant float. We're going to name it 100%, and we're going to call it 100% over here. Apply. Hold. I'm not going to send anything. Control. This is where we're going to want to do some control stuff. Box flow test and fail soft. Box flow test. We'll send it to 100%. Apply. Okay, so now in control mode, I'm going to look at the temperature So I know I need an input float. And we'll call this room temp. T. And then we're going to look at set point. All right. And we'll do some kind of calculation in here. So, oh, all right. So I'm gonna want another input over here because this unit will have some heat. We'll do cool slash. Uh, yeah, let's go with that. We'll do a mux block. Let's see. All right, so we'll do one is cooling, two is heating. Apply. Let me label that to make it easier on me. Cool. Okay. So now it's labeled here, so it makes it a little bit easier for me. I know this is going to go out there. So now, put that on top of that. Let's do some math. A subtract. So, let's say this is cooling. So set point minus room temp. No, we don't want that. Let's do room temp minus set point. Then we want to span and we could do the same thing with a PID. I don't really want to get involved with the PID too much, so I'm gonna go with a span. So we're doing output range, input range low, 0. We'll go 2. This is gonna go into cooling. Hide this line, make it look better. Hide that line. Hide that line. Because we're going to need another span block here. Need another subtract block. And now this one, we want if the set point minus the room temp and we'll do 2 degrees again. So just for giggles, I'm going to simulate it. Save changes, sure. All right, start simulation. So if we're in cool mode and my set point is 70 and my room temp is 70, we stay at 0, 70.5. We don't go anywhere. 71. Why is it not subtracting? It's weird. I do it backwards. 9. Some room here because that save changes. Oh, I know what's going on. Huh. We weren't in that mode, so the functions won't work. Gotta come up here. So we're in closed mode. So I gotta put this in control for this to work. Now it's in cool. So now we can have a set point of 70 and a room temp of 70.5. And damper opens 25%. 71. Damper opens 50%. 72. Damper opens 100%. So now that I'm thinking about it, span might just be a little too wound up. Maybe we'll go for 4 degrees. Maybe we'll go with 2. I like 2. So now we can get figure, stop simulation, yes. If I change this now. All right, I like the way this one's working. So what I'm going to do is not care about this guy. So I'm going to break this connection. Actually, I don't have to break this connection. I should be able to connect this guy up. Nope. I'm going to break that connection. Make this connection. Make this connection. Make this connection. Now I have to be a little careful in making this connection here. Because, no, I set this up as a cooling box, so it'll be fine. So we want the cooling set point, effective cooling set point, this guy. And so, heat cool, we can bring that in from the air handler. So we're gonna make a enum over here, call it heat cool. And we'll make a connection to that. Done. So now we're gonna come over here, or break our connection, change it to our VAV control program. There we go. Now, the auto calibration will still work on it because auto calibration is going to close it here and hold it off. And we're controlling it here. So that's it. We just made a pressure dependent VAV box, kind of rough and dirty way. Could have used some PID loops, but I really didn't want to. So yeah, I'm good with this. Thanks for watching.